Welcome back, everybody. Today we're going to be going over some examples of special functions. Some of them are absolute values, and then piecewise functions, and then we'll close out with step functions. And we're going to use Desmos to show all the graphs where possible. If there's any extra details that I need to show, I'll be putting those directly on the graph here. So the first one, as you can see, is an absolute value function. We see the absolute value of x minus 1 minus 3. Let's flip on over to Desmos here, and let's look at an absolute value function. I have it right here, f of x equals absolute. That's just the basic absolute value. It has a V shape. You can zoom in and just see that we're going up one, right one, up one, left one, and that's the basic absolute value. However, if I were to take the absolute value of x minus 1 minus 3, notice here minus 1 next to the x means we're going to be moving to the right one, and we'll be also shifting it down 3. So picture this graph move to the right 1 and down 3. And then we can see it from there. And they seem to be the same color there, so let me turn that one off, and there we go. We can see that. I'll try to simulate that back on the original one here. Let's do the just y equals absolute value of x. That is going to have this shape. But then picture that same function move to the right one and down 3. So it would have this look right here. There we go, and that's how it looks. You can see that on Desmos as well. Alright, moving on. Let's look at this one here. Given the parent function f of x equals absolute value of x, what is the graph of f of x equals absolute value of x minus 4? It's kind of the same idea here. Let's put the original right here. This is f of x equals absolute value of x. But then if we were to move it, have a minus 4 on the end of the function, same thing, just shifted down 4. And we can see that on Desmos as well. Again, here's the original, and then we shift it down 4. Alright, let's look at another one here. This time, okay, picture the original absolute value of x, but then we're shifting to the left 3, down 2, and this minus sign in front flips it upside down. So let's look at that on Desmos. Again, here's the original. But this right here, that's going to flip that upside down, so it'll be facing down. Plus 3 means shift left 3, down 2 means shift down 2. Here's how the function looks. Notice we went to the left 3, we went down 2, and we flipped it upside down. Alright, let's go on to another. Now we're going to switch gears. We're going to talk about what's called piecewise functions. I've heard them called the Frankenstein functions because they're bits and pieces of other functions put together. The function's going to behave like y equals, or f of x equals, in this case g of x equals x when x is less than negative 1, and I'll behave like negative x when x is greater than or equal to negative 1. There'll be an open and closed circle there. So let's look over at Desmos, kind of get this situation figured out here. Let's take away those. Alright, now here's how you enter on Desmos. The two functions are x and negative x, but it behaves like x when you're less than negative 1. It behaves like negative x when you're greater than or equal to negative 1. And notice how they enter it on Desmos. You put the little curly brackets. So there's the left side of the function, and notice we are just to the left of negative 1. Here's negative 1, and then let's go to the right of it. Now, Desmos does not show this, but for inequalities that are not equal to, there's an open circle on the end. So picture a little open circle right here. And since we are greater than or equal to on this one, closed circle right here. Notice this red line behaves like negative x. The black line behaves like positive x. All right, see if we can get that drawn here. Okay. So positive x when I'm less than -1. That would look approximately like this. And then it behaves like negative x when I'm greater than or equal to -1. Now when I say greater than or equal to -1, I'm talking about the x-axis. And then open and close circle. So pretend we have a closed circle here, meaning we include -1. And then on the other one, we have an open circle, meaning I don't include the endpoint there. So that's how the graph is drawn. So just Desmos helps us except for the open and closed circle. Make sure you understand the open and closed circles if you encounter exercises that show just that. Alright, so that's a piecewise function. It's like two functions, but it only behaves like those two different functions on certain intervals on the x-axis. Again, here's the when x is less than -1, and it behaves like this when x is greater than or equal to -1. Alright, let's look at another one. Now, the function is behaving like horizontal lines. Horizontal lines y equals 6, 3, and 5, but only on these intervals. It's behaving like y equals 6 when you're less than -3, y equals 3 when you're between -3 and +2 on the x-axis, and behaves like y equals 5 when I'm greater than or equal to 2. Let's look at Desmos and see how that will demonstrate this. Let's turn off our previous functions. And I have those piecewise again, and please notice how the intervals, how I'd note the intervals with the curly parentheses or brackets. Alright, we'll turn on -6 first, and we have to zoom out to see this. There's 6, and notice it is behaving like that when I'm less than or equal to -3, closed circle there. In between the intervals of -3 and 2, on the purple line, it behaves like y equals 3. See there, notice crossing the y-axis at 3 here. And then it's back up to 5 whenever I'm greater than or equal to 2. So that's how Desmos will graph it. Let's be a little more specific so we can see the open and closed circles. Alright, I'm going to start off with 6, y equals 6 when I'm less than or equal to -3. Keep track of our colors here. It behaves like y equals 3 when I'm in between 3 and 2. And then it behaves like y equals 5 when I am greater than or equal to +2 on the x-axis. Let's get everything coordinated here, and then let's identify open and closed circles. Less than or equal to 3, we need a closed circle right there. Greater than -3, less than 2, open and closed circles there. And then a closed circle right here showing that I'm greater than or equal to 2. Alright, let's look at another one. Another piecewise function, we'll call it. It's going to behave like the function x plus 1 when x is less than or equal to 0, and function 3x when x is greater than 0. Let's flip on over to Desmos. Again, notice the keys and the different symbols here. Here are the two functions, x plus 1 right there, and it's only going to behave like that, x less than or equal to 0. 3x when x is greater than 0. Here's x plus 1. Zoom in so we can see the values there. And here's 3x. There's the kind of a gap here, so it's kind of a jump. We would call this a discontinuous function. A lot of piecewise functions are discontinuous, meaning there's a break in between. On the red line we need a closed circle right here. On the blue line we would need an open circle. Let's see if I can simulate that. Let's do our red line here. blue line, 3x, that would cross up here. Let's get our circles right. Open circle right here, because we do not include the endpoint. Closed circle right here, because we do include the endpoint. Alright, moving on. And now we get to what's called step functions, and they are distinguished by a floor or a ceiling symbol. I know right here these kind of look like two little L's. Alright, well, first let's kind of look at the step function just by itself. This, if I did a step function on Desmos, we'll see the difference between the two here. Some call these rounding up or rounding down functions. So here's the floor. Okay, so basically floor for function x. So what this does is it rounds it down to the nearest whole integer. So if I'm anywhere from -1 to 0, it would be rounding down to -1. If I am anywhere between, if x is anywhere between 0 and 1, it would round it down to 0. Alright, and the floor being, there's closed circles on the left of each of these, open circles on the right of each of those. Again, let's say your x value is in between 1 and 2. Notice that's rounding it down. The y value rounds down to 1. So over here, if I'm between 1 and 2 on the x, the y value always returns up a 1. Alright, so the floor is kind of called the rounding down. Let's contrast that to the ceiling step function. So look here, between 0 and 1 on the x, it would round it up to a value of 1. And since it's ceiling, we're going to have closed circles on the right, this time open circles on the left. Alright, so let me go back to our screen. Let's say we just had y equals the floor function of x. Okay, so that rounds it down. So between 0 and 1 here, that always rounds it to 0. And I would have a closed circle, open circle. Between 1 and 2, that rounds it to 1. Again, closed, open. Between 2 and 3, that rounds it to 2. Again, open, close, and kind of has this stair step effect here. Now let's contrast that to the ceiling step function. The little symbols look like that, and that rounds up. So between 0 and 1, I would round up to 1 with an open circle here and a closed circle here. Between 1 and 2, that would round up to 2, open circle, closed circle. Like over here between 4 and 5, that would round up to 5. So over here I would be between 4 and 5, I'm going to round up to 5. And I think right here I got my endpoints mixed up. This should be an open circle. Yeah, closed circle on the right, open on the left. Alright, but this particular function is not that, so let me clear this out here. Alright, this is x minus 1, so it's the rounding down function. We call it the floor function. On Desmos you would enter it as such, and that whatever that rounding down function shifted down 1. Let's go back to Desmos and see how this works. Alright, undo this. Here we go. X minus 1. Notice where the stair step occurs. We are rounding down. Minus 1. And so we're going to have circles on the left, -1 here from 0 to 1, closed circle on the left, open circle on the right. Alright, closed circle on the left, open on the right, and then the stair step just goes accordingly.